This is the giant 1905 Corliss Steam engine here in the Grand Rapids Public Museum. I'm Darren, and this is the Industrial Revolution. The St. John's Table Company was originally formed in St. John's, Michigan, which is about 70 miles or 110 kilometers east of the Grand Rapids Public Museum here. Everything was going great, and they established a reputation for making top quality tables and dining room sets. Then they exhausted the supply of local hardwood. Instead of paying a lot of money to bring faux logs down to their factory, in 1905, the St. John's Table Company moved north to Cadillac, Michigan, which is about 100 miles or 160 kilometers north of Grand Rapids here, where there was plenty of local hardwood available. That's when this huge engine was installed. That giant two-piece flywheel is 18 feet or 5.5 meters in diameter and weighs just over 12 tons. That's connected to a much smaller wheel that drives the factory's overhead line drive system. Going from the larger wheel to the smaller one works kind of like gears, with the smaller wheel going much faster than the larger one. That line drive system connects through belts and pulleys throughout the factory to every machine, like this one at Greenfield Village's Armington and Sims machine shop. The whole shop here is run by this system. Check out my video on these systems, linked down in the description, but here's the short version. When you see a twisted belt, that's to reverse the direction. Some machines have multiple pulleys of different sizes, corresponding to different sized pulleys up on the main shaft. Moving the belt between pulleys changes the machine speed, just like on a 10-speed bike. Remember, these belts are just like gears, really. And those little discs running back and forth? Those are to clean the dust, lint, whatever, off the shafts, and keep them clean and rust-free. Now let's go back to Grand Rapids and this huge Corliss steam engine built by Hoven, Owens, and Rensselaer Company. Hey, just real quick here, and we'll get back to the video in just a second. If you can help me out, like, share, subscribe, all that stuff that really helps out the channel a lot. And comment. I love reading the comments, and I usually respond to them really quickly. Also, there's an affiliate store link down in the description. And if you can help out financially, either a super thanks here on YouTube or become a member over on Patreon at patreon.com/industrialrevolution or membership here on YouTube. Thanks a lot. Let's get back to the video. Wait a minute. I thought you said this was a Corliss engine. Yep, it is. The Corliss engine refers to the valve mechanism design, which was originally designed by George Corliss in 1849. Once the patent expired, of course, others were then free to use the design, and plenty of companies did. You can see the valve gear here. Notice how incredibly smooth almost everything's running, except that piece over on the left, of course. That one's obviously not doing so well today. Now check out that Hartnell governor that's barely spinning. This engine is running way slower than it normally would run, obviously. If the engine were running around normal speed, the balls, which are held both by gravity and springs, would be moved partway out by centrifugal force. If the engine speeds up, the balls move out further. If it slows down, the balls move back in. You can see the connecting rod connecting the governor back to the valve system. That's the critical feedback system common to most stationary steam engines. It lets the engine automatically adjust for changing loads. Let's imagine that they feed a huge timber into a saw, which puts a huge sudden load on the engine. Normally, the engine would slow down instantly, then speed back up. But the innovation of the Corliss design is that the engine responds way faster, so that the speed barely changes at all. In the textile mills, which were the original users of Corliss engines, that means they didn't break potentially hundreds or even thousands of threads, meaning you didn't have to shut down a bunch of machines and rethread them every time your load changed. In the furniture factory, it means you didn't get uneven cuts, planing, or sanding on the furniture, giving you the best quality furniture without a lot of reworking required. Let's talk about the specifics of this engine for a minute. First, the total engine weighs about 33.5 tons. It has a single 24-inch bore, 48-inch stroke, double-acting cylinder. It produced over 400 horsepower and what the manufacturer claimed was unlimited torque. One surprising thing is the belt on top, which appears to be too loose. This is actually correctly tensioned. If it were tight, then when it got colder, the belt would contract and it could either seize up or even break. As it is, if there's a huge sudden demand change, the belt might slip momentarily, but it'll pick right back up again. One other interesting thing with the setup here, notice all the oil cups. They're absolutely everywhere. This is important, but you may not realize why. A lot of steam engines were built before ball bearings were in common use, and instead of ball or roller bearings, they used what was called journal bearings. Unlike ball bearings, the journal bearings, which are also called slide bearings, plain bearings, and probably a dozen other names, have very flat surfaces running against each other. Between these surfaces, there's a very fine layer of oil. Maintaining that layer of oil on every bearing surface requires constant attention, which requires all the oil cups. While these bearing systems are normally closed up, and you can't normally see what's inside, they left one of the covers off here, so you can see that it's actually stuffed with cloth. This oil-soaked cloth acts like a wick, keeping the journal bearing well lubricated. In 1954, the St. John's Table Company retired this engine, but left it in place. Hey, it weighs 33 tons. No one wants to move that if they don't have to. Like at many other shops, it was replaced with an electric motor to run the overhead line drive system. The electric motor just took a lot less work to keep everything running. Gradually, as older machines died or they needed to add new ones, the new machines had their own electric motors, so they were pulled off the line drive system completely. That continued until 1985, when the factory finally closed down completely. When the factory closed, this engine was abandoned in place. It sat for a decade before, in 1994, it was carefully dismantled and brought to the Grand Rapids Public Museum. Have I mentioned that this engine is huge? So huge, in fact, that the engine actually had to be installed before the building was finished, and then they built the rest of the building around it. When they moved it to the museum here, they didn't want to run a steam boiler. They did want the engine running, though. To do that, they installed the small electric motor down here, tucked away, hidden underneath it, in behind the tensioner. This is fairly common in museums, as it's a lot less work to run a small electric motor, and you don't really need the speed or the torque that you'd need if this were actually running in a factory today. And it's actually a better exhibit running at a slower speed. A lot easier to understand what's going on. Today, with stairs wrapping around it in this huge open space, you can examine the engine from every angle, not only around the sides, but even from up above it. So this engine didn't stay in use very long, unfortunately. With all the advanced features on it, as you probably guessed, it was kind of near the end of the steam engine era for large factories. And after a couple decades, they gradually moved away from it. They shut down the steam engine, put an electric motor on to run the overhead line drive system first. And then, as the equipment had to be added or replaced, they simply didn't use the line drive for the new stuff. They put it on simple standalone electric motors for each piece of equipment, which is the way you do it today. When the factory closed, this was abandoned, and it sat abandoned in the factory for even more decades. Finally, it was rescued and brought here, restored and put on display here in the Grand Rapids Museum. And that's why this is the Industrial Revolution.